Okay, so we're gonna start graphing quadratics. It's only a one-day lesson. I kind of consolidated it, but what I want to do with this is I just want to get through it. So, standard form of a quadratic equation. You guys should be familiar with this from Algebra 1. F of x is equal to ax squared plus bx plus c, okay? Where a is the number in front of x squared, b is in front of x, and c is the number that has no x next to it. Next thing is parabola. A parabola is a U-shaped graph of a quadratic equation, which you guys should be familiar with, but I just wanted to go over the vocabulary. Okay, it says find the vertex and sketch the graph of the quadratics below. Check by graphing in Desmos. We don't have to check by graphing Desmos. I'm just going to graph these in Desmos really quickly so you can see the shape of these. So we have 4x squared, negative 4x squared. So we have our 4x squared looks like this. Right here, this part right here is called the vertex of our parabola. It's where it changes direction. If I put a negative into it, well, what happens to our graph? It actually goes from up to what's called concave down. So I'm just going to do a little sketch here. Okay, so it's a narrow parabola. There we go. There's this one. And there's this one. And so all I wanted to talk about is this general rule. So if a is greater than 0, so do you see that this is a positive 4, then the graph is concave up, which means that it looks like this. If a is less than 0, then your graph is going to be concave down. And I'm sure that you learned this in Algebra 1. Okay. Here's something new. If the vertex parabola is the lowest point, it is called a minimum. Okay, and so right here, my vertex was 0, 0. This is also the minimum. Okay, and if the vertex of your parabola is the highest point, this is called a maximum. Okay, and so my vertex was 0, 0. Okay, the other thing you need to know about parabolas is they have what's called an axis of symmetry, and we'll go over this. An axis of symmetry is the line where you can fold your graph and it'll fold on top of itself. Okay, so if you have a point here, you're going to have a point right here if I folded it over. This axis of symmetry, this is is an equation. It's x equals 0. So this line right here, the equation of this line is x equals 0. Same one here. This axis of symmetry would be here. This would also be x equals 0. That's my axis of symmetry. So the turning point of the parabola is called the vertex. To find the x value of the vertex, I'll explain this formula thoroughly, but it is negative b over 2a. Okay, and those are the parts of standard form. To find the y value of the vertex, you substitute the x value into the function. Okay, so all you do is a little bit of substitution. The vertical line that divides the parabola into two equal parts is called the axis of symmetry. The axis of symmetry formula is going to be x equals negative b over 2a, or x is equal to the x value of the vertex. And here, you're always going to write, this is always x is equal to, you always have to have x is equal to something. Last thing is the concept of real solutions. Real solutions, when I use that vocabulary term, that's going to be the same as your x-intercepts and zeros, and we'll talk about that when we go through some of these graphs. So I gave you kind of a play-by-play as to what you do. So first thing you do is you find your x value vertex, then you substitute the x value in to find the y value, write the vertex in the middle of the table, pick 2 points to the left, 2 points to the right, and substitute of the vertex and put them in the table. Substitute those values in for x into the equation to fill the table and plot the connected points, okay? You always need, at least for this class, I always want to see 5 values. So just graph the functions below and identify the characteristics listed. For this first one, my vertex, I want to find it, so I use the vertex formula. Vertex formula, x is equal to negative b over 2a. So I go back to my equation, -3, my A value is -3, my B value is missing. This is actually, this right here is my C value. My B value, since it's missing, we're going to say that that is 0. So I'm going to substitute these values in, so it's going to be -0 over 2 times -3, which is 0 over -6, which is 0. So I know the X value of my vertex is 0. The Y value of my vertex, we'll define the Y value. I actually substitute this X value into my original equation. So my original equation was Y equals -3x squared plus 5. I want to plug 0 in for X. So this is going to be Y is equal to -3 times 0 squared plus 5. So my Y value is going to be 5. And so I write that in my table. 0, 5 is my vertex. And I also can plot that 0, positive 5. So I have my vertex right here. Now I need 4 other points. So we'll talk about also, we'll talk about the axis of symmetry in a minute. So I want to pick a point to the left. So I'm going to pick, let's say I'm going to pick an X value of -1. And then I'm going to pick an X value of -2, and then 2 X values to the right. I'm going to pick +1 and +2. So 2 to the left, 2 to the right. Okay, how do I find my Y values for this? So what you're going to do is you're going to substitute the X value in. So this is going to be into the original equation. Now make sure you put parentheses around it. So this is going to be 3 times -1 squared plus 5, which is going to be -3 times +1 plus 5, which is going to be 2. Okay, I do the same thing here. -3 times -2 squared plus 5. That's going to be -3. Now -2 squared is +4. Make sure you put those parentheses around your negatives. Plus 5. That's -7 plus 5. Or -12 plus 5. Oof. -12 plus 5, which is equal to -7. Is that right? Okay, yeah. Oh, sorry. My brain broke for a second, so that's going to be -7. So I plot those points, so it's going to be -1, 2, -2, -7. So I have half of my graph plotted, which is delightful. Okay, now let's look at the other side of my graph. So if I do this right, in theory, and you guys can use this, so I have my axis of symmetry here. What my axis of symmetry is, my axis of symmetry here is going to be x equals 0, since x equals the x value. I know if I have a 1 point to the left, this point is 1 to the left of my axis of symmetry, then I should have 1 point to the right. If I have 2 points to the left, I should have 2 points to the right. Because if I plotted everything correctly, then it should be symmetric with, I should be able to fold my graph along that line. It should fold on top of itself. So what we're going to do is I'm just going to go through and do my substitution here really quickly. So hopefully without my brain messing up, 1 squared plus 5, that's going to be -3 plus 5. This is a 5 here, which is 2. So yes, indeed, 1, 2. And you guys see that that's there. And then this is going to be -3 times 2 squared plus 5, which is going to be -3 times 4 plus 5, which is -12 plus 5, which is -7. And sure enough, that is -7. So here's the other half of my parabola, and that's how you would graph. So 2 and then -7. And so you can use your axis of symmetry, find 2 points, and then you can use the axis of symmetry to plot another 2 points. So my axis of symmetry here is x equals 0. It's not always 0, it's just in this case it is. Now for this next one, we're going to have a lot of questions to ask. I just want to do another example really quickly. So again, we go through to find my vertex. X is equal to -b. So A in this case is 1, B is negative 6, so x is equal to negative b, so it's negative negative 6 over 2 times a. X is equal to 6 over 2. So the x value of my vertex is 3. So I put that in my table. I substitute it in. So to find my y value, that's going to be 3 squared minus 6 times 3. Always plug it into the original problem. Y is equal to, and you can just put this in, so minus 18 plus 9. Y is equal to 9 minus 18 is negative 9. Negative 9 plus 9 is 0. So it's going to be 3, 0. Okay. I pick 2 points, so I'm going to go 3, 2, 1. So 2 points to the left, 3, 4, 5 points to the right. Make sure it's symmetric. This is 1 away, this is 1 away, this is 2 away, this is 2 away. So I know my vertex is 3, 0. I know that this is my a value is positive, so it's going to be a maximum. I also know that the axis of symmetry is going to be x equals 3. So those are the first few things that I definitely know about it. Okay, so I go with 2, I plug 2 in, so this is going to be 2 squared minus 6 times 2 plus 9. Again, you can plug it in your calculator. It's going to be 4 minus 12 plus 9, which is negative 8 plus 9, which is 1. And then this one's going to be 1 squared minus 6 times 1 plus 9, which is 1 minus 6 plus 9, which is negative 7 plus 9, which is, or negative 5 plus 9, which is 4. Okay, if I did this right, then this should be 1 and this should be 4. Okay, because it should be symmetric if I found my vertex in the right place. So again, I'll do 4 squared minus 6 times 4 plus 9, which is going to be 16 minus 24 plus 9, which is negative 8 plus 9, which is also 1. And then the same thing here. So, but again, you can use symmetry if you feel like you have the vertex in the right spot. The points here should be symmetric to the points right here. So, so we have 2, 1. We have 1, 4. And so I have half of my parabola. I'm just going to draw my axis of symmetry. So even without the other half, I know that this is 1 space. So I'm going to have 1 space here. This is 2 spaces away. So this is going to be 2 spaces away. So there's the other half of my parabola. And again, you don't have to have your axis of symmetry. I'm just drawing it. So this is x equals 3. All right. So my domain is going to be from, I know that can be distracting, is from negative infinity to positive infinity. This is always for all quadratics. It is always negative infinity to positive infinity. My range, well, my graph starts right here. My lowest y value is 0 and goes up. And so up would be to positive infinity. My increasing intervals, I'm going to go back with the sparkly pen. It's increasing from here to here. Remember that you used x values. So it's increasing from 3 to infinity. My decreasing is going to be on the opposite end. It's going to be from negative infinity to 3. So it's decreasing from negative infinity to 3. My real solutions, it's actually going to be my x-intercepts. So it crosses at 3. So I'm just going to write 3. My y-intercept is actually, and this is a little cheater, but this actually goes up to 9. My y-intercept is where x is equal to 0. So you could approximate with your graph. You could look at it in Desmos, or you can plug 0 in because that's where your y-intercept is where x is equal to 0. So it's going to be 0 squared minus 6 times 0 plus 9, which is just going to be 9. My end behavior, as x goes to negative infinity, so this is on the left, what's happening to my y is going up, so it's going to positive infinity. As x goes to positive infinity, that's actually going to be my right. My graph is going up, so it's going to positive infinity. Okay. So I know those are a mouthful. We actually have 2 more examples to do with fractions. If you're comfortable with this is fine, but I'd like you to at least see one of the fraction ones. So same thing as before, using decimal sketch and compare. So we have 4x squared and 1/4 x squared. So I go back here. We have, well, we know what our 4x squared looks like. We're going to compare that to our 1/4 x squared. What you notice is that my 1/4 x squared is a lot wider. It's still concave up, but it is wider. Okay, so you have your 4x squared, which looks like this kind of, and then you have your 1/4 x squared, which was a much wider graph. So what's the difference here is this a value, okay? And so we say, well, when the absolute value of a is greater than 1, your graph is actually going to be, narrow. When a is less than 1, the graph is going to be wide. Okay, so we have our wide and our narrow. I just have some tips here about multiplying by the reciprocal. You can read them as you may. The only tip I have for these ones are just a little bit different, is the fact that if you have a fraction, when you're picking points to fill in the table, always pick x values that are divisible by the denominator, or numbers squared that are divisible by the denominator. And I'll show you what I mean in a moment. So let's go through this one. We're going to go through the same procedures. So I know in this case a is 1/4 and b is -3. I know to find my vertex, x is equal to -3 over 2 times 1/4. Okay, so that's going to be 3 over 2/4, okay, which is going to be 3 over 1/4, and dividing is the same thing as multiplying by the reciprocal. So this ends up just being, the x value of my vertex ends up being 6, just a really nice 6. So dividing is the same thing as multiplying by the reciprocal. And I have an example of that here. 8 over 2/3 is the same thing as 8 times 3/2. So that's the trickiest part of this. The rest of this, if you can remember that, you should be good. Also picking your points. So I substitute 6 in. 1/4, if you don't want to deal with the fractions, Dasmus will do this for you. So you have 1/4 6 squared minus 3 times 6 plus 2. That's going to be 1/4 times 36 minus 18 plus 2. 9 minus 18 is -9. -9 plus 2 is -7. So it is, my vertex is 6, -7. Okay. All right. So 6, -7. Okay, so let's pick 2 other points. Now I'm gonna be careful with the points that I pick. So I'm not gonna pick 5 because I can't. 5 squared, I can't divide it by 4. I pick 4 because I know if I put 4 in here that these will divide out. So I'm going to do, this is going to be 1/4 times 4 squared minus 3 times 4 plus 2. And you can just have a standing in your Desmos scientific calculator. Right here I happen to have it. So we have 1/4 and we're going to put 4 in, and you can just put the equation in and just change the values so you can do this. So when I put in 1/4 times 4 squared minus 3 times 4 plus 2, I end up with a negative, wrong thing, I end up with a -6. So, but you guys can see as I go through, this is going to be 1/4 times 16 minus 12 plus 2, which is going to be 4 minus 12 plus 2, which is -8 plus, or which is -8 plus 2, which is -6. So you'll get the same thing. When I pick another point, let's say I don't want to pick 3, I'll pick 2, and you're like, Miss Holly, 2 is not divisible by 4, but 2 squared is. So I would do this. This is going to be 1/4 times 2 squared minus 3 times 2 plus 2, and you have to trust me. I'm actually going to finish this up in a different color. So this is 1/4 times 4 minus 6 plus 2, which is 1 minus 6 plus 2, which is negative 5 plus 2, which is negative 3. And this is what I mean. You can actually just go back into, you can go into your scientific calculator here, and all you have to do is change your values, and you see that instead of making stupid arithmetic mistakes, which I tend to do, you have your negative 3. Okay, so we have, so this is going to be 4, negative 6, 2, negative 3. And so I kind of have negative 6 and 2, negative 3. Okay, so I have this graph. It's a weird looking graph. It kind of looks like this. All right, I know it's going to be symmetric. On the other side, so this is 4, 6. So I know if I have a point here, I'm going to just kind of draw my axis of symmetry here. So I have 1 point here, there's going to be 1 point there. If this point is 1, 2, 3, 4 over, then I'm going to have 1, 2, 3, 4 over. And you can plug these values in, okay, and figure it out from there. Or you can just use your axis of symmetry and just kind of count. So I would actually, if I were actually picking points on the right side, I would pick 8, because so this would be 1/4 times 8 squared minus 3 times 8 plus 2. And if you plug all of that in, oh, I put this point in the wrong spot. I am so sorry, guys. This is so dumb. I knew I did something wrong. Okay, so this is 6, negative 7, 4, negative 6. There we go. That looks 4, negative 6. There we are. I apologize. And 2, negative 3. And so that, I knew that looked funky. I'm sorry. There we go. And then we do the same thing on the other side, and that's the flaws. If you plot your points wrong, like I just did, you might have a problem. So this is 2 spaces this way, so this is 2 spaces this way, this is 4 spaces this way, this is 4 spaces this way. So there we go. And so that's what my graph should look like. So in theory, it should be 8, negative 6 should be there. And you'll see that if I just replace this, and you guys can just do this, if you don't want to use symmetry, you can just plug in 8, you end up with, do you see that it's negative 6? And then also, I'm not going to pick 9, I'd pick 10, because any of the even numbers squared are going to be divisible by 4. So that would be 1/4 times 10 squared minus 3 times 10 plus 2. You end up still getting your negative 3. So this was 6, negative 7, and my axis of symmetry is, of course, x equals 6. So x equals 6 is my axis of symmetry. The only lesson I want you to take away from that is picking numbers, if you're going to graph, picking numbers that when you square them are divisible by the denominator. So I'm just going to do one more. If you feel like you need one more, stay with it. If you don't feel like you need one more, and I apologize for that mistake, move on and do the homework. I'm going to talk about your attributes here as well. So for this one, my a value is negative 1/3, my b value is negative 2. X is equal to negative b over 2 times negative 1/3. So this one's a little bit messy. It's going to be positive 2 over negative 2/3. Okay, when I multiply across. So dividing is the same thing as multiplying by the reciprocal. So I multiply this by 3 over negative 2, so I flip it, okay? And so this is going to be 6 over negative 2, and so the x value of my vertex is going to be negative 3. Okay. To find the y value, I plug my x value in. You can do this in Desmos. So this is going to be negative 1/3. Make sure you put in parentheses negative 3 squared minus 2 times negative 3 minus 4. That's going to be, if you want to know how to do math, negative 1/3 times 9 plus 6 minus 4. that's going to be negative 3 plus 6 minus 4, which is going to be 3 minus 4, which is negative 1. And so my y value here is going to be negative 1. Okay, so we want to pick points that are divisible by 3. So if I'm picking points to the left, so we have negative 3, negative 1 here. So if I pick points, I'm going to pick, so negative 3, I'm not going to pick negative 4, I'm not going to pick negative 5, I'll pick negative 6. Negative 6 would be a good number, because I know that that's divisible by 3. If I was going the other way, I wouldn't pick negative 2, I wouldn't pick negative 1. 0 is actually an excellent point to pick. And then also if I were going to the right, I wouldn't pick 1, I wouldn't pick 2, I'd pick 3, because I know that that's divisible by 3. And then the other way, I did negative 6, then I'm going to go, okay, negative 7, negative 8, negative 9 is going to be good to pick. And the reason why is because I want to pick numbers that are divisible by 1/3. So even if you're using a graphing calculator or whatever, you still need to pick points or whole numbers so I can clearly see the points on your graph. So, so for this here, so my vertex is negative 3, negative 1. My axis of symmetry is going to be x equals negative 3 because it's always x equals the x value of my vertex. I plug this one in. This one's actually a delightful one. So I have negative 1/3 times 0 squared minus 2 times 0 minus 4. When you put all of that in, I end up with this being negative 4. And then for this one here, this is going to be negative 1/3 times 3 squared minus 2 times 3 minus 4, negative 1/3 times 9 minus 6 minus 4. Again, put it in the graphing calculator if you're more comfortable. So this is going to be negative 3 minus 6, which is negative 9. Negative 9 minus 4 is negative 13. And I should not have picked one that was that kind of a weird one. Negative 13. And then if so I'm going to do, so the next one is 0, negative 4. And I picked something off the graph, so I apologize for that. 3, negative 13. It would be somewhere around here. So I have half of my graph. And so we expect it to be kind of a little bit wider than normal. On the other side, so here's my axis of symmetry again. I have 3 spaces one way, I do 3 spaces the other way. Of course, that takes me to my negative 6 here. And so that should be at negative 4. And then I have my negative 9 here. And so I know that that's going to be negative 13 because it's the same value here, but you can always plug in, and I would actually plug in to make sure, but you can use your axis of symmetry too. And I would prefer 5 points, this one just happens to be off. My domain, I have an arrow to the left and an arrow to the right, so that's going to be from negative infinity to positive infinity. It's always the same for quadratics. My range, my y value, this is a maximum, okay? And so my y value stops. Anytime you have a maximum, what's going to happen is you're actually going to be starting at negative infinity, and my graph stops at a certain point. Well, my graph stops at negative 1, so that's going to be my range. My increasing intervals from negative infinity to negative 3. Remember that it's where you look at your x values. So it's going to be negative infinity to negative 3. My decreasing intervals starts decreasing again at negative 3 and goes to positive infinity. So this half here. My real solutions, actually there are going to be, in this case, there are none because it does not cross the x-axis. My y-intercept is right here at negative 4. My end behavior, well, if I put negative infinity here, that's actually going to be on the left. And what's happening, my y value is going down, so I'm going to write negative infinity. And on the right-hand side of my graph, so right-hand side would be positive infinity, so this would be to the right. And my y value is also going down here, and so this is going to be negative infinity. Okay, we're going to review this next class, so I know this is a lot of information in a long video, but I wanted to put 2 things in at once because I wanted a day for review. So